So we were talking about the Atwood machine. What was the Atwood machine? Well, it was a nice construct. It was two masses hanging from a rope, except to be accurate, we had to make the math a little simple. We said the ropes will have no mass, the pulley will have no mass or friction, because that would change the question and introduce extra forces and make this more difficult. But I said to you, actually, we use this idea fairly often. Elevators are actually Atwood machines. There's always a counterweight that's the same mass as an empty elevator car. And what that means is once people step out, the motor can shut off and the elevator car will stay there quite nicely. You don't need to expend energy to hold it in place. In fact, what that means is all the motor has to move is the mass of the people in the car. It does not have to move the mass of the car itself. That just naturally takes care of itself with the counterweight. We said our strategy was going to be, we're going to do a free body diagram. We're going to do winner minus loser equals m all a to find acceleration. And then we're going to pick one of the masses to find tension, unless they don't give us both masses. So in example 5 and example 6 where we've left off, they didn't give us a mass. It says, given that M2 is 4.3 kilograms and it's accelerating downwards at 2.5 meters per second squared, find A, the tension, and B, M1. Do you see why, Rowan, I can't go winner minus loser equals M all times A? I don't know M all. Okay? So that's your first hint to ding, 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 ding. I got to plan this out. Which mass do I know? We're going to do a free body diagram on M2. That's our strategy. So instead of doing all, finding A, and then looking at one mass, we're going to start with one mass, find what we can from that, and work our way to the other mass. Got the argument? What are the forces acting on M2? Get the obvious one. And I'll call it M2G. What else, kiddo? Yep, what you're feeling right now. Is there a normal force? Not unless it's sitting on a surface. Now, I have to tell you which way this is accelerating, and I did in the question. If I don't, this is impossible. Which way is M2 accelerating? Down. Which way is the winning direction? Same answer. Down. Which force is winning? Oh, gravity. No, same answer, down. Now, so I was walking you through the 3 steps you do in your head. Which way is accelerating? Down. So which way is the winning direction? Down. Who's winning? More specific here. Read me that. Who's losing? What's that equal? Which M? M2A, because I'm just doing one mass right now. Now, why is that so handy? What did A want me to find? Swappy dance. Yes? And so we're going to get this. M2G minus M2A, that equals tension. Rowan, do you mind? Can I put the T equals on this side? Because that's where we're used to. How big was M2, Rowan? They told me somewhere up there. G, 9.8, minus 4.3. And they told me the acceleration. They said it was 2.5. I just looked for the meters per second squared and found the number right next to it because I just looked for units. Okay. Let's go to our calculators, folks. How big is the tension in this question? I don't know why I put that in brackets. It's not a fraction. I didn't need to, but I did for some strange reason. Do you get 31.39? Okay. 31.39. I'll write 31.4, but I'm going to use the 31.39 in part B. Riley, okay with that? Got your calculator here, Riley? You do? Okay. Pardon me for asking, but you know. Hey, Riley, what's B want me to find? M what? Say it again. M what? Say it again. This is a job for a free body diagram on M1. By the way, I still can't go winner minus loser equals M all A because I don't know M all. Let's look at M1. What are the forces acting on M1? Get the obvious one, Riley. Yep. M1G. What else? Yep. Which way is M1 accelerating? Yes. Which way is the winning direction? Same answer. Give me my equation. Who's winning? Who's... Yes. Who's losing? And I'm only doing the forces on M1, so that equals M1A. You could solve this now, actually going winner minus lose equals M all, but it's a much more complicated equation, Jackson. I would avoid it. Riley, what did you say I'm trying to find? How many M1s are there in my equation? How many would I prefer? Let's get them to the same side. I'm going to plus the M1G over. Okay? I don't know where I'm going, but I'll do that. I'll get M1A plus M1G, or M1G plus M1A. How many M1s do I have? How many would I prefer? You know, it'd be really cool. It'd be really cool if there was a grade 9 math operation that I could pull out of my back pocket that would cleverly change this from 2 M1s into 1 M1. And there is. Who remembers? GCF. I can factor this, Courtney. Who knew that factoring was useful? I can write this as M1 bracket A plus G. In your head, Riley, just multiply the bracket out. Do we get the line above here? I think we do, so we have factored correctly, yes? Thumbs up. How many M1s do I have now? How many would I prefer? Woohoo! How would I get the M1 by itself? I need to move the bracket over. What's the bracket doing to the M1? Adding some. So how will I move the bracket over? Starting to see why I did all that formula manipulation stuff with you at the beginning of the year? To try and come up with an equation for each one of these or plug in numbers right away. It's just yucky. So if I hear you correctly, you're telling me that tension divided by A plus G. And Riley, do you mind? I'm going to put the M1 equals on this side. What was the tension? I've scrolled down. It was 31.39. Don't round off. Don't use a rounded off answer. If you can avoid it, use your answer button. And what was the acceleration, Riley? And G, I know, is 9.8. By the way, there's a bit of a built-in error check. Since M1 is accelerating up, I know it's smaller than the 4.3. The 4.3 must be heavier, and that's why it's winning. Divided by bracket 2.5 plus 9.8. And I get 2.5520. I'll go 2.55, 2.6 if you round it off to 2 sig figs. 2.55 kilograms. Okay. This is probably the first time, or one of the first time, that I've introduced something to you and then Courtney ran it backwards. In other words, I introduced the Atwood machine to you where I gave you both masses and said find the acceleration, find the tension. And then I said, okay, what if I give you either the acceleration or the tension in one mass? Go backwards and figure out what the other one has to be. In Physics 12, if those of you that have told me you're signing up for Physics 12, you'll hear me always say, if I teach you how to do anything going forwards, I expect I can ask you to reverse engineer it fair game from day one. I won't do an example every time. I will once in a while for the nastier ones, but I'll always say, oh, here I gave you the launch velocity, we found the range. If I give you the range, I figure you can find the launch velocity now too. What's your homework? So I already said number 1 and number 2 and number 3. Number 4, I haven't done one quite like number 4 yet. In number 4, I didn't give you any mass, but I gave you both tension and acceleration. Really what I'm saying is there are 4 things, M1, M2, tension, and acceleration. If I give you any 2, you can find the other 4. See if you can figure that one out. I skipped 5 and 6. 7 is good. 8 is good. 9 is good. and I'm going to give you a take-home quiz. Quiz, please. This one has some teeth. So we're starting off right away with an Atwood machine, giving you both masses. Then number 2, your hint here is normal force is not mg. See, there's an extra vertical force mucking around with it, but free body diagram. Number 3, asking you for the acceleration. That's just a conceptual one. Number 4, draw a free body diagram and then find the acceleration. 5, here's friction, find the acceleration, find the tension. And then number 6, here's a question where I'm asking you to find M2, given that I've given you M1 and I've given you the acceleration. Your hint is find the tension first and then find the missing mass. These are tricky. Can you all look at lesson 6, number 12? No, lesson 7, number 12. I think it was number 12. Well, just lost the question. Let's bring it back, Mr. Dueck. 3, 2, 1. This one here, this was a scholarship nasty question. And again, let me emphasize, I'm not going to ask one this tough, Kenzie. Sorry. I've been doing that again for a while. I don't know why. So a 32 kilogram box is placed on a scale inside an elevator. By the way, whenever I'm talking about a scale, which force am I talking about if I'm ever asking you to tell me what the scale is reading? What does a scale measure? Okay, and you're going to see that shows up fairly often. The total mass of the elevator plus contents is 725 kilograms. Suddenly, the supporting cable breaks and the elevator accelerates downwards, but it's slowed slightly by the emergency brakes. While the elevator is falling, the scale reads 210 newtons. The normal force is 210 newtons. That's what I hear. Okay. A says, draw a free body diagram showing the forces on the box. There's the box. What are the forces acting on the box? Get the obvious one. Okay. The box is sitting on a scale, so is there a normal force? Yeah. The question is, bigger, smaller, or the same size as mg? Which way is the box moving according to this question? Down. Is it speeding up or slowing down on the way down? Slowing down. So which way is it accelerating? Which way is the bigger unbalanced force? There's the free body diagram on the box. B says, draw a free body diagram showing the forces on the elevator. Okay. What are the forces acting on the elevator? Get the obvious one. I'm going to go big MG for big mass elevator and little mg for box, or I could have called it M1 and M2. Which way is the elevator moving? Is it speeding up or slowing down? Which way must there be an unbalanced force then? So I know that arrow's there. Which force is that? Normal force isn't what's slowing this one down. I think brakes or friction, pointing up this time. Okay. C. What's the acceleration of the elevator? You can't find it. What you can find is the acceleration of the box inside the elevator. And since the box is inside the elevator, I think that's also going to be the acceleration of the elevator. You follow the argument there, Franz? So I'm going to use this free body diagram here. Franz, who's winning? Who's losing? So it's going to be normal force minus little mg equals little ma. How would I get the a by itself? Good. and this is going to be mass of the box. So the acceleration of the box, which must be the acceleration of the elevator, is going to be, what was the normal force? They told me 210 newtons. Ha-ha! That's why they gave me that piece of information. Minus, what was the mass of the box? They told me 32. 9.8 all over, or divided by 32. Now, I worry we might have the wrong winner here. Let's find out. 210 minus 32 times 9.8 divided by 32. I got a negative acceleration. What does that mean? Even though this box is falling down and it's slowing down, it's still accelerating down. Rowan, I misread this question. When I said it slowed slightly, I thought that meant it was slowing down. I think what they're saying is it's just not accelerating at 9.8. So I need to quickly change my free body diagram. I'm going to make normal force smaller. Don't worry about it, Evan. I wouldn't take marks off, because the free body diagram gets you thinking about this and then you would catch it. And for what it's worth, friction should be shorter. Now, did you do this in pen?
I did this part, yeah.
Easy fix. Look up. Okay? So for this one, and let me bring back both diagrams that were wrong. Did you make the normal force too big? I'd clue in. Ready? Still an easy fix. Who's winning? Winner plus. Who's losing? Loser minus. See that? Loser minus, winner plus. Do we have to rewrite everything? Don't type. Wait a minute. I think I can just backspace and edit. A minus sign goes there. Negative sign. A plus sign goes there. I get the same magnitude, but I get a positive answer. And that's why I've said to you, you know what? Who's winning? We kind of guess. And if you get a wrong answer, wrong winner, you'll notice, because that negative acceleration would catch your eye. But it's Carlos, pretty easy fix. Did I have to scribble out or erase a whole bunch of stuff, Evan? No. Did I have to rewrite a bunch of stuff? No. So the acceleration is 3.2375. But what I wouldn't have done is ignored that negative. I wouldn't have just said, the negative magically vanishes. It would have got my attention. The only thing that might change, had there been in this question here friction, we would have had friction pointing the wrong way. We might have had to swap it, and that would give us a different magnitude. 3.2375. Kenzie, you got this far. You said D. Okay. Who's winning? Who's losing? What's that going to equal? Did you just see how to do the rest of it now? Because what do they want me to find? Well, not mu, the force of friction, which is not the same as mu, but they want me to get this by itself. Swappy dance. And I'll get big M, which is 700 and whatever it was, G minus big M, A, and A will be my answer from part A. That's going to be the force of friction. There you go. So if you handled that, that was a Physics 12 scholarship exam question. And the tricky part was visualizing what the free body diagrams had to be, recognizing that a scale measures normal force. So when they told me what the scale reads, they were telling me the normal force on the box. Excuse me. Recognizing that the box was accelerating the same as the elevator. So even though it said find the acceleration of the elevator, you couldn't, but you could find the acceleration of the box inside the elevator, which must be the same as the elevator. You take it the rest of the way yourself, that should work. Oh, and again, big M is going to be 725. And that's why they said total mass of the elevator plus contents, because if they hadn't said that, because now I'm looking at the elevator and the box itself, it better be both masses combined. Is that all right? So I'm going to pause.